my screen is visible?
Yes, sir.
Okay, sorry for the inconvenience to all the participants. I waited you for 15 minutes. There was a problem with their power fluctuations were there. So power is coming in, therefore shifted to some other place. In the morning session, we discussed about some of the basic concepts of IoT. I think these concepts you already come across maybe in previous phase one also. We discussed in the morning session the overview of Industry 4.0 and the concepts as well as the architecture. Now, if I want to implement something, for example, if you brought IoT, if you brought Arduino kit, you need to learn the code. We need to have software, and we need to write Python programming, or we need to write embedded C programming, or if you want to use any application. Now, how these functionalities is going to work? Because in the morning session we discussed about the architecture, which give the overall idea or the design of IoT if you want to implement anything. Now, if I want to implement something, first of all, we need to know the protocol architecture of IoT. Suppose, for example, I'll give because there are other branch faculty were there apart from CS and EC. Any other faculty were there? Gujarat is like mechanical, civil people were there.
Yes, sir. Few of the faculties are from General Science Department, Civil Engineering Department.
Oh, okay. If such a case, then okay. Let me explain. This is a little bit tough part. Anyway, I'll try my best to make you comfortable. Now, see, for example, why we require now. If I want to run this FDP program, it is not that much easy. Right? Why? In the sense because getting a fund. First of all, we need to apply for the fund to the AICTE. Right, AICTE should give the fund to your college. Right, applying is one process. Right, coordinator they are going to apply for the fund, and then they are going to give fund to your college to conduct this FDP program. Now, this is step number one. Right, this is step number one. Then what the organizers will do, in the sense, they will prepare the brochure and they will go for call for participation. Right, they will send to all over India. Right, we are conducting an online refresher program on IoT. So interested participants may join this FDP program or may attend this FDP program. Now, based upon that, they will get some registration. They are going to get it, and then the faculty will be registered. So registered applicants will be there. Then the coordinator should also do what is now. If they need to prepare a schedule. Right. Now, how they will prepare a schedule? First of all, they need to identify the resource persons. Right. So first, they need to send a request that we are conducting so and so FDP program, and then the faculty member, the resource person should give the acceptance. Then I need to include which topic they want to include, where I need to include all these things. See, it is a very tough process. It is not that much easy to conduct a FDP program. If I want to. If this FDP program want to be a successful one. So it's a big headache for the coordinator to organize this 6 weeks FDP. Now, what is that happening is they're performing some sequence of operations. Means first, what is the first operation? They are going to apply for AICTE. AICTE is going to give the fund for that. Then they go for call for participation. Then participants will be registered. Then requesting all the resource persons. Then request will come from all the resource persons. Then we need to prepare the schedule. After the schedule, then we need to prepare an inaugural. Then we need to organize it in a way. So what is that we call them as? So in order to conduct a FDP program of such a nature, it's a very tedious process. It's a very difficult process we have. Same thing, IoT also is a very complex system. It is not that much easy, whatever we learned theoretically. If I want to implement practically, first of all, we need to aware of some protocol. Protocol is nothing but sequence of instructions. Suppose, for example, I'll give human protocol. How the human protocol will work, I'll tell you. Suppose, for example, there are two persons were there. Right, two persons were there. Now they want to communicate it. Assume that one boy is there, right? We can call them as, and then girl is there, which you could have it, but girl is there. Now, a boy want to ask, what is the time now? What is the time? Right now, if the girl is very serious, then she will fit. Why you are asking time to me? Because why we are asking that? Why he is asking time? Right? She will look differently. Why means we don't know what the boy is and what type of behavior he has. I don't know any information about this boy, and even the boy doesn't know anything about the girl, and he is asking a time, right? Without knowing all that. So what is that? He requires some mechanism is required in order to ask the time. This is not the way directly to ask the time. Now I want to assume that now if I want to hi, then if I'm sending hi, if she's willing to send hi only, I can do process. If she's not sending, then she's not interested to talk with the boy. Right? First of all, let me introduce hi, and if say hi, then I need to introduce myself. I'm so and so, and the girl should introduce her name. Then I can ask what is the time. Now, what is that? A sequence of process is going to happen here in order to organize. We call them as what? Human protocol. This process is called as a human protocol. Now, when it comes to the, especially in the IoT, IoT is a very complex system. What is required in the sense, we required a protocol architecture of IoT. That protocol is nothing but it is going to provide a communication. Suppose, for example, how the physical devices will communicate with the network topology or network technology. How the network technology will be connected to the backbone network. How the fog computing will be integrating to the cloud computing. How from cloud big data analysis can be there. Well, some mechanism is required there. Some process is required. So therefore, in this session, we discuss about the protocol architecture of IoT, the challenges of IoT, because as the people who are, I don't know, I've seen very few members who are completed a doctoral degree, who want to do PhD or who want to do MS by research, then you can take this as a one of the good area where you can work it out on that. So first of all, we need to know what are the various challenges. Then we need to know the Internet of Things communication models we have. Like for example, now it is very easy to tell this is a 7-level model, 7-layer model. Now every level integration is very challenging. It's not that much easy. So like for example, boy and girl, they are both are two different people, right? Now how to synchronize these two is the biggest challenge we have. Like for example, you see, now I assume that now what is that is going to happen is that now I'm the resource person. Now there are very different faculty communities there, like heterogeneity. One from few people from CSC, few people from ECE, few people from CSC, few people from science group, right? Which they have some less basic knowledge in this thing. They may be good in some other aspects. Then some people will be there from civil department, say civil engineering. So we are a heterogeneity here. Now, teaching computer science course, definitely it will be boring for EC people, science people, as well as civil people. Now, how can I teach IoT so that all these people should show interest in answering my questions? So, therefore, what we need to know, we need to know some communication, integration of that sensor networks, wireless sensor network to the internet. We need to integration is required. Proper integration means I need to take the opinion of EC people, I need to take the opinion of CSC people, I need to take opinion of science group people, and I need to take this opinion of civil, where we can use this IoT. So therefore, finally, we'll end with the device and the cloud communication model, how it is going to happen. In tomorrow's session, after once the theory is learned, in tomorrow's session, if possible, I'll show you a hands-on approach so that you can do on your own and you can show to your students through how the hands-on approach will work. Right. Once we understand the theoretical aspects. Now assume that we are having various types of sensors. And then we are assuming that we are having some networking components. And then we are going to have data storage and data processing. And then this application. So this is component number 1, this is component number 2, component number 3, and component number 4. So this now every level we require some protocols to communicate. It's not that much easy to communicate. This some required, some protocol is required, some protocol communication is required. So protocol is something like it's provide a communication between two different entities or two different entities which is going to happen. So we'll try to see the protocol architecture of IoT, which is a very important part we have. In the morning session, we discussed about the physical devices and controllers. We have network connectivity. We have discussed edge computing, cloud computing, data abstraction, application, and process and collaboration. Now, what we are going to do, the physical devices and controllers, which we call them as what? Technically, we call them as industrial. Industrial IoTs, we call them as what? Objects. The physical devices and controllers are called as objects. Suppose, for example, we have an Arduino kit. That Arduino kit will consist of what? Microprocessor will be there, memory unit will be there, power unit, management unit will be there, sensor unit will be there. So that Arduino kit board will have so many modules which will be integrated for that, and various sensors through USB we are going to connect. That Arduino kit we call them as what? Object. That Arduino kit we call them as what? Object. The object abstraction, the connectivity is called as what? Object abstraction. Means we can connect with Wi-Fi, we can connect with the Ethernet, we can connect with Zigbee, we can connect with some hotspot, right? Anything we can connect with some gateway. Anyway, some other process which we are going to apply in the form of what we call them as an object abstraction. And then we are going to have three different one is the edge computing, data accumulation, data abstractions are nothing but services. They service oriented, right? For example, we have now if you see we have an engineering college. In an engineering college, there are some service branches for there. Can you know? Can I know who are giving services to the engineering branches? Can I know from the faculty who are giving services? In engineering college, we are having some service courses will be there, which they are going to provide facilitating to learn ECE course or to learn a computer science course or to learn some civil course. What are the service courses that comes under in engineering? Anyone? Like, for example, we have a physics department. They're providing the services to all the circuit branches. We have a mathematics department. They're going to provide service to the engineering department. We have a chemistry department. We have a English department, humanities department. So what they are going to provide is service providers, service to all the branches. They are not unique to one branch. They are going to provide like training and placement is another one. Right. So these are the people who are going to provide in order to have a good community. All these people, not only the circuit branch, same branch faculty will be, other branch people, other faculty also will work to make a good engineer. So here also in IoT, we are going to provide different types of services we can have. So that we call them as a service management. It's data abstraction is a service management. It is a service management. Communication, cloud computing is a service to the IoT device. Edge computing is also service. And then we have an application layer, and then we have a business layer. So the 7-layer model we are going to convert into 5-layer. And then, if you want to go in technically, the object and object abstractions are called as what? Infrastructure protocols. The objects and object abstractions are called as what? Infrastructure protocols. And service management protocols are called as service discovery protocols. Now, if I want to provide a service, suppose for example, I want to take it. Now, I assume that now I want to request I want to request the mathematical department to explain M1, M2 courses. Right, or linear transformation I want to learn. Now we request the mathematical department HOD to depute one faculty to teach our students on these courses on Fourier transformation. Now we are, what is that? First we need to discover a service, then only we can get the request for that. Service discovery protocols. And then we are going to have what? Application protocol. So Every layer will have some rich set of protocols that need to be supported. Now we'll try to see what are those protocols we have. Now you already know that the LTE Advanced and RFID, we can call them Electronic Product Code Global, RFID. I think most of the people have come across FASTAC. FASTAC, you have come across FASTAC? After the lunch, sitting quiet is very difficult, isn't it? I know, being a faculty member, sitting quiet is very difficult, isn't it? So you can interact, so that definitely it will be interesting. Yeah, Madam, sir has they have responded. Yeah, FASTAC is RFID based, so we can have it. So what we can do here in the sense that we use IoT as a rich set of devices we can have, like for example, we can use electronic product code, and one of the popular standard which we can call them as, I think, Wi-Fi. Technical word of Wi-Fi is 802.11. Ethernet, wide LAN we can call them as 802.3. Okay, we can have a Zigbee, 802.15.4 Zigbee, like home automation, your TV, smart TV. We have a smart refrigerator. We have a smart mobile. If all the devices want to control, then we require what? A Zigbee topology. We require a Zigbee network need to be established. So what we are going to do, we are going to use IEEE 802.15.4. We are going to use it. And then we are going to use another proprietary technology called Z-Wave. Now all these things are comes under what? Physical devices or physical layer. Above that, there is a link layer. We can call them as what? IEEE 802.15.4, which is a personal area network, which is widely used. Now, these two are called as what? Network technologies. These two are called as, comes under what? Network technologies. Then above that, we are going to have a network layer. There is a one interesting layer is there. Now, I want to ask a simple question. I mean, so to understand for the civil people or to understand from the other branch people. Now, assume that there is a small kid is there, right? One small kid is there who is 6 months old or 1 year old. 1 year old, kid is. Now, what is that? The person, one family friend is going to come, right, to visit, to see the kid. To see the kid is visiting the house. Now, whatever he is communicating, whether the kid can answer, whether the kid can answer, whatever the communication is happening from the outsider, the outsider, whatever the outsider is doing here, outside person, he is communicating. The kid can answer the same communication. No. Now, who is going to help? Who is going to help? A mother, right? Mother is the right person because we know that the mother is the right person to help. We can call them as, which we call them as, because the kid can understand the mother can understand the kid language, right? Mother can understand the kid language. 1 year old kid, we can have it. Now the mother is there. Now whatever the communication is coming from the outside person, the communication will come to the mother, and the mother will give the instructions to the baby, and baby will respond. Now, baby here is nothing but what? Low power device. A low power device we can call this. And here mother is a very good translator. We call them as what? 6LoWPAN. 6LoWPAN is nothing but IPv6 low power personal area network, where it can understand the data which is coming from the internet and to the low power devices. So this 6LoWPAN is one type of a adaptation layer which we are going to use it. And we are going to use IPv6 protocol as well as IPv4 protocol, right? And then we are going to have a routing protocol which we are going to see with the help of the RPL. RPL stands for what? Routing protocol for low power and lossy networks, which is used in 5G network also. It reaches for that. And then we are going to use a transport layer. That's above the transport layer is we use two types of transport layers. One is the TCP, another one is the UDP. Unfortunately, we are not using TCP. We are using the UDP. Now, all these three comes under what? Internet protocols. This one is the network technology. This one is what? Internet protocols. Now, this internet, then above that, all these two, the internet protocols plus the network technologies are called as what? Infrastructured protocols. Means that the objects and object abstraction, are called as what? Infrastructure protocols. Means all these things will be there in the object and object abstraction. If you take any Arduino kit or Raspberry Pi kit, all this information will be available inside. Okay. Then above that, we have a service discovery protocol called multicasting domain name service. Domain name service with service discovery, which you are going to use it, right? Or universal plug and play mechanisms can use as a service discovery mechanisms, which we can use cloud computing or we can use big data analysis as a part of it. So service discovery protocols also we can use it. And finally, we are going to have the application protocols, like we can use this type of various protocols, which are the categorization of the protocols we use for the implementation of any IoT device. Do you have any doubt here? You understood? These are the application web transfer protocol. Do you have any doubt? Yes, sir. I think someone is. Okay. 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 Thank you. Now, how to connect two different IoT elements is the biggest challenge we have. Now, for example, I'm going to take what I'm going to take. A few people they will take Arduino kit, Arduino device. Other people will take Raspberry Pi. Other people will take a mobile field communication. Someone will take Bluetooth low energy, Bluetooth. Someone will take MQTT, message telemetry transport protocol, message queuing telemetry transport protocol with sensor network. We have. Someone will take a Zigbee network. Right? Then this fellow will use Ethernet. This fellow will use Wi-Fi. This fellow will use mobile field communication. This fellow will use Bluetooth low energy. This fellow will use a sensor network 802.15.4, Zigbee network 802.15.4. It is going to use it. Now, all these things are called as what? Network technologies. Network technologies, which makes use of what? Which we discussed, the physical layer as well as data link layer will be available. Next, above that, where we can use internet protocols, someone will use bus topology, someone will use Wi-Fi, someone will use gateway to connect it to the service devices which you are going to come to. So we are going to connect it to the cloud. Now, which device comes under right? All these things are through network connectivity. Through this network connectivity only, we are going to connect it to the cloud. So these are called as what? Service discovery protocols. From these service discovery protocols, we can use as a application web transfer protocols. These are all the application web transfer protocols if you want to connect it to different applications. So this is the way how this protocol architecture of IoT will be used. Okay. Now I request the participants, please see this one carefully, how whole rich set of IoT protocols can be used in the IoT. This is the diagram which will give a clarity. If you want to do some research work, you can do all the different type of people. And other branch people, other non-circuit branch students, they can, faculty, they can work it out on different types of applications. Now, if you observe carefully this diagram, which will give a lot of clarity, we can use sensors, we can use RFID, we can use actuators, smart meters, GPS, cameras, and thermostats. Now, all these things need to be connected with either long-range communication or short-range communication. This one is a short-range communication. We can use Zigbee, we can use Bluetooth, we can use near-field communication, we can use low-range wireless personal area network. And whereas this is a long-range communication with Sigfox and LoRaWAN. And these are access gateways we can have it, whether we can connect with wired, fiber coaxial cable, cellular network with LTE, Wi-Fi, which is a digital subscriber line, satellite communication, power line communication, LTE, WiMAX we can use. All these things are connected to the IP-based network. And this is a service platform with which you can use it as a cloud computing, service-oriented architecture, and point-to-point protocol, P2P protocol, which can have a P2P network. We can have. And above that, we can use n number of applications like smart logistics, smart manufacturing, smart management, smart metering, smart health, environmental monitoring. So this is a data collection phase, this is a data transmission phase, and this is a process management and utilization phase we have in the data flow in the IoT, which you are going to talk about. Okay. Now, please see, this is a way where we are going to work it out on the IoT protocol stack. We have various types of sensors. These are all various types of sensors. Now, all these sensors, somewhere we need to connect with Zigbee, which makes of 802.15.4, 6LoWPAN, 802.15.4, RFID, IEEE 1451, wireless LAN 802.11p, or Bluetooth Low Energy. And all these things above that is the mother, which we can call them. 6LoWPAN is the mother. And what we are going to use it, we are going to use mobile IPv6. Means our mobile gateway which is going to work. On top of that, we are going to use UDP, and then we are going to use either COAP or MQTT. Now, therefore, now mobile IP we are using, the mobile is nothing but what seamless. Mobility is there, right? Which we are going to do. If we want to implement anything, right, first of all, we need to know the protocol architecture or protocol stack of IoT. If I want to implement something inside of the application. Now, we'll try to see quickly. I think anyone has come across, studied computer network apart from CSC, other branch faculty, they have studied this computer network. Or at least you have come across internet. Okay. Now, yeah, very good. So now see, if you see internet, now someone will call internet is a network of network. Someone will call them as a wide area network, right? Someone is called as internetworking. Yes. Now, if you observe carefully, how these internetworking of devices is going to be connected is nothing but because if you call internet is nothing but what? TCP/IP protocol soup. It has TCP/IP protocol soup. Means if you have any device, it should be enabled with the TCP/IP protocol. Now, if any device want to connect to the internet, that device should have a capability of internet protocol soup. That we are going to study now. Now, what we are going to do, if you see the TCP/IP protocol stack, whatever theoretical we studied tomorrow, we'll try to implement so that you can understand much effectively. Right? Why I'm giving tomorrow itself, today itself I can start it, but if any faculty is interested, they can install in their laptop. For that purpose only, I postpone for tomorrow's session. Now, TCP/IP protocol stack, and this is the IoT protocol stack if you want to have it. Now, the first layer is called as we can use a rich set of personal area network with 802.15.4 physical layer. Then MAC layer is nothing but IEEE 802.15.4 MAC we can have. Here we call as network access like Ethernet, token ring, token bus, Wi-Fi. All these things comes under the network access. Next one, we have an adoption layer like mother. We are using 6-LoWPAN, IPv6 low power personal area. Here in TCP/IP, it is not applicable. Right? And in network layer, we use RPL and IPv6. And then here it uses both the IPv4 protocol, IPv6 protocol, and IPv4 protocol. And transport layer, we use only UDP, whereas we use both UDP as well as TCP. Now, I want to know for the other people to understand, what is the difference? Can anyone give me, what is the difference between UDP and TCP? Why IoT supports only UDP? Anyone?
Actually, TCP is connection-oriented protocol, and UDP is connection-less protocol.
Very good, madam. Very good. Now to understand for the other non-branch students what I'm saying, don't mind, it's an example only. Now, what I'm using UDP and TCP in the sense, for example, now when I'm asking a question and user is, now as a resource person, I want to ask because I want to make more interactive. Now, the resource person asking some question, a resource person, right, asking some question to whom? To the participants, to the participants asking the question. Now, what is happening? Now, TCP is something like what? Now, whatever the question, if I get the answer only, I'll go to the next slide. I will not, otherwise I will not go to the next slide. That is, we call them as what? We are expecting some acknowledgement. TCP is going to expect some connection oriented. Connection oriented means it should be some acknowledgement oriented. Because if you have any doubt, then I'll stop. I'll stop until unless if I get answer from the participant side, I will not proceed to the next one. That is the TCP. UDP is something like that. Irrespective of right, if you are not giving answer also, I'll go to the next slide. I'll ask. There is no answer. I'll go to the next slide. That is UDP. Means it is a connectionless. It is a connectionless because irrespective of the other side, I'm going to deliver the data. That is a connectionless. And whereas connection oriented, no. If you give the answer only, I'll go to the next slide. Otherwise, I'm not going to do the next slide. You got it? For the other people who are not aware of UDP and TCP, connection oriented and connectionless. You got it? No? Okay. Now this is a network. I request the participant. You can take the screenshot of this. Tomorrow we'll try to implement this one. Right now, this is a concept which we're going to explain tomorrow. We will try to implement this network. Low power wireless internet we can have it. These are the low power devices we can use it. These are the low power devices we can have it. These are low power devices which we are going to get it. All these things are connected to the broader router. Now this is a broader router. This is another broader router we can have it. And this is IP network which we are going to connect it. And then this is the IP device which we can have it. So this is called as a low PAN extended IP network. Tomorrow we'll try to implement with the sensor network which are going to be connected to the internet which are going to use it. I request the participants, please take this screenshot of this. Tomorrow we'll try to see through a hands-on approach. Once if it is over, please tell me so that I can go to the next slide. Over. Shall I go to the next slide?
Sure, sir.
Okay, thank you. Now, if you see here, now what we are going to do in any architecture of a 6-LoWPAN or a low power networks we can have. Now, this is the one network we can have. These are the various sensor devices which are going to be connected. Now, R stands for router and H stands for host or edge node. Edge node, we can call this. So, and through router only, it is going to communicate to the broader router. Please recall in the morning session we used this is a network and this is a broader router. That broader router is connected to the your router, and router is connected to the internet. We can have it if we are going to have it, or through some PC also we can connect it, or through router also we can connect it. All right. So this is a network architecture of 6-LoWPAN network which is going to happen. Okay. Now this is the way how the device-to-device communication is going to work. Right now, suppose for example, I told you, we have a smart light bulb from manufacturing A, and then through Wi-Fi, it can be through Wi-Fi or Bluetooth or Z-Wave or Zigbee. I'm going to connect the switch, light switch from manufacturer B. The manufacturing A and B both are different. Light was manufactured by different person, switch is manufactured by different person. Now we need to ensure interoperability among the device-to-device communication. That's one important point we need to know. Right? Next one. Device to gateway level model. Now, how to device to gateway model is going to happen in the sense we have a device with a temperature sensor, a device with the carbon monoxide sensor, which you're going to have it, and then through local gateway. What is that local gateway? It can be Bluetooth Smart, it can be Wi-Fi, or it can be 802.15.4. We call them as a low range personal area network. Through network protocol only, whatever we discussed just now, through network protocol only, because this fellow can understand IPv6, this fellow can understand IPv4. Through the cloud only, we are going to connect. Therefore, what we can call them as device to gateway model only we can connect. That's second one. You can see one more. Now, if you see this picture carefully, you will come to know how RFID based sensor is going to work. How RFID based sensor is going to work. Now you observe that. Now this is the Arduino RFID kit we have it. These are these things. We call them as what? Zigbee network. And this is a 6-LoWPAN network which you're going to have it. Now this Arduino kit with RF sensor enabled RFID. And then this one is nothing but we are having two types of tags usually. Anyone know about RFID? How many tags we have?
Active tags and passive tags.
Very good. Very good. Active tags and passive tags. But which is more widely used? Active or passive?
Passive tags.
Very good. Now, why the answer is passive tags? Because it requires less energy. Battery power is less when we compare with the active. Active tags requires battery energy. Right, so the more passive tags will be used, especially to enable for the IoT applications we have. Now we have an active RFID tags, which is battery enabled, and then we can take any two sensors with 802.15.4, right, with the 2.4 GHz radio frequency system. Now this is one network we can have. This is one network we can have. This is another network we can have. This network is different and this network is different. Now, for this Zigbee network with RFID reader, who is having a capability of reading, and then this reader will take the data and it is going to send through the IoT gateway, right? And this is the IoT sensor gateway or reader, which is sending to the IoT gateway, and through that we are going to connect it to the external network. So this is one example which we can use as a RFID based sensors. RFID based sensors. Next. The third category is if the device directly want to communicate. from the morning reference model, if sensor device want to communicate directly, then we need to have a device with a temperature sensor, device with carbon. There is no gateway here. Directly I'm connecting to the internet through cloud, through internet, which you're going to have it. So the application service provider is going to provide. This is the third category, device to cloud communication model. And then what we are going to have, if you see here how it is handling here, we have a sensors, we have actuators, and these are the IoT devices with the Z-Wave, ZigBee or Bluetooth Low Energy or RESTful, HTTP or RESTful, and through some GPRS, Wi-Fi with COAT, I'm connecting to the cloud. This is the way how this layered architecture of the sensor to the cloud integration is going to be happening. So this is a sensing layer, this is a coordination layer, this is we call them as what? ZigBee coordinate, end devices connected to the coordinate. Okay. And finally, the final one is that what is that? What the communication model we have is nothing but a backend data sharing model we have. Now, if you see here, what we are going to do, light sensors will be there, and then through COAP or HTTP, which we can have, we are sending to the application service provider one through the backend. So through the backend, we are connecting to some other service provider which can be connected. So this is another level of data communication sharing model. You got it, all of you? Do you have any doubts here up to this before I close this part?
So please continue.
Yes. Right. Now it is very easy to explain simple words, but technically there are some challenges for that. Now, what are the challenges of IoT is the biggest part which we need to be very aware, because it's very easy to explain the concepts, but when we go into the detail, there need to be a lot of research work need to be done. Now we are talking about the technology called IoT. Now IoT is going to have various applications, and it is going to provide very good services which you're going to have it. And these services need to support certain features or characteristics. Some characteristics is required, which you're going to have it. These characteristics is going to provide certain services, and we are going to apply in certain applications. But the very important one is the challenges we have. Now, these challenges need to be solved if I want to apply in a specific applications. So therefore, we are going to study various challenges of IoT. Now, if you take any key IoT platform, because different tomorrow some other like drone has some different requirement, right? Or Arduino kit has different requirement. CDC 100 is another requirement. Raspberry Pi kit has another requirement. If you take any platform requires some key components. What are those key components? First of all, whether your platform supports scalability. Because when we talk about IoT is going to deal with millions of devices, not one or two. Whether it is going to handle the million scalability issue. That's it. The second category is it is going to supply the real-time information, real-time data, which we call that real-time data insights, whatever these devices generating, right? Those real-time data need to be persistent. Second category. The third category is that the devices are intelligent enough, the devices are dynamic enough, so that why we call them as a dynamic. A node can be entered anytime. It can be entered or it can leave anytime. They are dynamic in nature, and they are very intelligent devices, right? And then the data which are getting, it can be huge volume of data which we need to convert that data into a small data. So intelligent and dynamic. And the fourth one is whatever the technology we are talking about, right? Internet is a distributed network, right? 5G is a distributed network. Fog computing is a distributed network. So when we talk about all these technologies are in distributed nature, we are not interested with the centralized because of certain problems are there, like a single point of failure will be there. Then the fourth part is nothing but the security and the privacy issue we have. Right, the fourth part is nothing but what? Security and privacy, which is a very key for any platform. So key requirement for any IoT platform is scalability, real time, intelligence and dynamic, distributed, decentralized, security and privacy. So apart from the other challenges, we need to solve certain important challenges like connectivity challenge. It is not that much easy to have a connectivity. Right? There are certain problems. Suppose if your laptop is not connected, now definitely what you will do, you will call the network administrator to troubleshoot it. So what we require, we need, if you are connecting millions of devices, there will be challenges with connectivity issue. First one. The second one is the security issue. Right? The third one is the performance and scaling factor. Scaling is another issue we have. Longevity, because we need to know whenever the devices are there, how much time it will be in sleepy mode, how much time it will be in active mode, what is the lifetime of that device. All these things we need to be we need to aware of that, which your protocol need to adapt to that longevity. Next one. Then hyper connectivity, because we are connecting with some different types of different devices with heterogeneity. Now, hyperconnectivity is a very, very, very important, and is one of the important challenges. Next one is privacy issue. Now, can anyone tell me the difference between privacy and security? Anyone? Anyone? Both are same or both are different? Maybe EC people. Anything? If you know, okay. If you don't know, I'll answer it, because these two are very important in IoT. Yeah, Vinay sir has told this is different. Can you tell, sir, why it is different and how it is different?
Sir, security is more about unauthorized access.
So good, very good.
Yeah, and privacy is more about like keeping my data with myself, like not giving more privileges to the people.
Access privileges, more access privileges to the people.
Yes.
Very good. Right. Right answer. Thank you for right answers. Now, what I'm going to tell, suppose for example, I think you people are very good enough of Bitcoin and cryptocurrency. Now, what is happening here? Now, just to understand whatever we have. Now, assume that there are two persons per there. Now, two persons, they want to exchange some information. Right? They want to exchange some information. Now, what is happening here, for example, now if I want to ensure, for example, now I want to have the some what we can call them as the Aadhaar card. Right? Now I want to give the Aadhaar card. Right? Now, if I want to get the Aadhaar card of the two people, first I need to get from the authority. Means from other website only I can access it. Now, if I want to get the Aadhaar card from this one, right, I need to go and I need to register. Then what I'm going to get it? I'm going to get an OTP, one-time card. Then to whom the OTP will be available? Only to the authenticated persons who have registered with that Aadhaar card. For their mobile, that OTP is going to come. Once the OTP is verified, then you are ready to download that Aadhaar card. Now you got a digital Aadhaar card. Right? Digital Aadhaar card. Now this digital Aadhaar card which you're going to have. Now this digital Aadhaar card you want to send to the other person. Now here we call them as secure. Now, how it is secure in the sense? Because only authenticated persons can download the digital card. No other person can access it because he is authenticated to download the Aadhaar card. That's why SAR is told authenticated people or authorized people will get it. Now, I'll give some privacy issue which is going to be happening. Now, what I'm doing here, because this is a digital Aadhaar card, if I send if I send to the other person, everyone can see it. Everyone can see my digit and they can claim it. Instead of that, what I'm doing, I'm going to apply some hash algorithm like SHA-256 of that Aadhaar card. Now I'll get some unknown text. We call them as what? Unknown text, which is not revealed. Unknown text. Now this address, unknown, we call them as what? Some address of that fellow. So that the other person will not be known what type of address it is, whether it is an Aadhaar card or some other information. Means I'm hiding certain information so that if any authorized person want to know, then I'll tell you. If I want to ensure what you have sent, if I want to know, then I'll tell you perform SHA, then you'll get that address. So privacy will be ensured. Yeah. Right? Privacy means definitely we are going to hide certain information and we are going to send it. Okay, you got it? You understood? Right? And then we have a proprietary ecosystem which we might have it, because all the IoT devices are not new. We can have some proprietary models, open source models will be there. But how can we integrate those models? Is that legacy systems? What about the existing infrastructure that are available or period of years? Whether we can apply for all these devices for the IoT also, future IoT. Then transparency, because IoT is going to give a lot of information to the outside world. Because whenever the device, whatever the device we have, once it is connected to the internet, once it is connected to the global internet, which you can have. Now, this is a local or it will be global? Anyone? Whenever a device is connected, whenever your mobile device is connected to the internet, it is local or it is global?
Can you please repeat the question?
Whenever a mobile device is connected with internet, it is a local, it is isolated, or it is a local area network, or it is a global wide area network. The device will be visible to everyone. Okay, I think I'll give an answer to you. No, it is not local, it will be global. It will be global. Okay, now I'll give an answer to you. My screen is visible. My
Yes,
web
sir.
browser is visible. Web browser is visible.
Yes, sir.
Right. Now, what I'm going to take it, I'm going to take a search engine called Shodan. The Shodan is a search engine for Internet of Things. Right? So, it's visible now. My screen is visible to all the participants.
Yes, sir. It's visible.
Yes, madam. Yes, madam. Thank you. Now, what I'm going to take, suppose, for example, now I want to know, I want to know that IP camera. The devices which are connected to IP camera, I want to view it. So for that, what we need to know, I'm going to use Shodan for the IP camera, which is connected all over the world. I can see it. Let me see whether now you see this is IP camera which is connected, which is connected in Brazil, which is connected in the United States, right? Which is connected in Australia, right? Whose IP address will be visible to all the total information we can. When I click that one, I will get the total information of that D-Link DCS, which is connected to that IP camera, which is connected. Even the encryption is not there, authentication is not there. I can masquerade it. So the major problem is the security and privacy is the biggest problem when the devices are connected to the internet. You are able to follow me? So this IP network HTTP configured, all the information is available, right? So for example, I'll take a Zigbee network or Zigbee. Zigbee devices which are connected to the internet I want to view what are the devices which are. Once I know that the IP addresses, and once I know that all these things, information will be connected to automatically. In Malaysia it is connected, in Australia it is connected. So this I can connect to, once I know that all the whole information I can easily retrieve it. Right? This is the way how it is going to be. We can see and we can have it. You are able to follow me? Yeah. Okay. So that's why we are going to use, especially therefore it is the biggest challenge we have, especially in the IoT. So this is a transparency, because everything is visible, whatever it is happening, and more vulnerable to the attacks also. And the standards, now we need to concentrate on a lot of standards, hardware and the software standards, which lot of standardizations will be there in IoT. That's the biggest challenge we have. Cost constraint is the biggest thing, is because now whenever the cost is high, definitely people will not take. If cost is low, there will be some compromise will be there with security and privacy. So cost constraint is also biggest factor, especially in the IoT. And then finally, configuration. Zero configuration is required, because these devices are low power devices where the configuration should be less efficient. So we can say that how to drill the IoT deposit, because now if you see, the data is the new oil. The data, because when we talk about the IoT is going to give a new data, a real-time data, dynamic data. So definitely it is a new oil. Data is a new oil when we use IoT. Now, are the businesses are willing to share the most valuable assets? That's the biggest, because if you see now, because the data is the new soil, and if you see a soil without a rain, a soil without a rain is equal to data without the security. There will be a lot of security breaches which is going to be. So this, so we can say the success of IoT is purely depends upon 6 important parameters. First one is the trust. The second one is the identity. The third one is the privacy. Fourth one is protection. Fifth one is safety. Sixth one is security. Because now the very important one we need to know that the trust among the people and the services it is going to be provided. But we are going to such a beautiful word called trust, because we are trusting each other. Even we are trusting the devices. Later, this one should not be misused. Right? And then identity, validate the identity of the people, services, I think is a very important. Because when we are dealing with millions of devices, identity is a very important. Who are using which device? And privacy, device ensure personal and sensitive data should be kept private so that it cannot be visible to the outside world. Right? Like my Aadhaar card should not be known to the outside world. Right? Though it is connected, though it is linked with PAN card or some other, it cannot be revealed to the outside world. We require some access privileges. Then safety need to be provided for the devices, infrastructure people, and then maintaining the security of data service people. Therefore, we can say, to conclude, the success of IoT is purely depends upon 6 important parameters: trust, identity, privacy, protection, safety, and security. Then we'll end up with the applications now, because where we can use these IoT devices. If you see here, already this feature is already available. If you go through that, a car will give automatic alarm if the driver has made any mistake. Already in all the high-end cars, this thing is already there. Now, even in more advanced version, like if you see in BMW car or some other cars which have it, if the driver is somewhere is sleeping, if he is sleeping, automatically the car is going to stop. It is not going to start. It is going to identify. So that's that type of sensors enabled there automatically in the car, where to save the human life. Next one, a bag will send a reminder message through some RFID or something, right? If the owner forgot something to print, that's another where it is used. Next one, a cloth and a washing machine. The cloth will tell the washing machine about the requirement of the water temperature. If you see the smart washing machines which are there at your home, you can use already whatever cloth you are using, automatically we are going to adjust the sensors will be activated, and whether it requires hot water or cold water, whatever detergent is required, whatever material it is used, and whatever color it has, all this information accordingly it will be adjusted and it's going to perform. So definitely we can say that the life will be changed completely with the technology of the IoT. Okay. Now these are the various applications of IoT we have. These are the various applications. Like for example, we are going to take smart cities, smart environment, smart water, smart metering, energies, retail management, logistic, industrial control, smart agriculture, farming, domestic health, home automation, and healthcare. But there are certain areas where IoT is very, very, very essential. Like if you see, because where the less involvement of the people, the more problems were there, like smart cities were there, right? And then we are going to have smart environment is required compulsory. We require smart water, right, which we require, and then industrial control we require, agriculture we require, and health definitely is required. We can say that definitely these are some of the applications that IoT is going to rule definitely with the help of these machines. Now, just if we take an example of smart cities. Now, smart city is not a single concept. It requires multiple challenges it has. Now, if you see, we are going to have the smart waste management. We need to have it, right? Smart walking system we require, right? We require smart public transportations we require, right? And these are the public transportation we can have. Now, we require water, greenery, right? Water or smart waters we require. Traffic management we require. Parking system we require, and CC surveillance. If we connect all these things, then we can say that Internet of Things connects up well things which can happen. So every challenge is we need to solve it. Then if we want to make it a smart city, therefore it's not much easy to have. I think this is not going to be covered. Maybe in today's session will take more time. Do I have any doubts here? Okay. I think here. Now, before I go into the technical hands-on session, I request, I think, how many people are having laptops and how many people are having desktops so that tomorrow we can practice?
Absolutely no problem, sir. You can conduct the hands-on session by tomorrow.
Yeah, tomorrow, madam. Tomorrow we'll have a hands-on session.
Sure, sir.
But only two things I require. If the people are ready for that, I'll send two links to you. you can instruct them to download those things.
Yes, sir. We'll post it on the WhatsApp group of the participants.
Yes, madam. I'll forward now, madam.
Okay, sir.
This is the which is available to all the members. Workstation, like VMware workstation, player evaluation. You can download this one. Right, I think usually we recommend to install Ubuntu, but I think various people were there. It's very difficult to go for Ubuntu. Therefore, I'm going for Windows based, so that I think you people are already having Windows. So therefore, this is a link where you can download VMware workstation, VMware player workstation, where you can download it. Right, VMware workstation player, you can have it. You can download it. The other one is the other one which I downloaded, instant. Usually we have a latest version, but we will try to do with these two. It will take right these two, which is available. The link is available. Madam, I think it's available to all the people. I think in the chat box, it's visible, no?
It's visible, sir.
Yes. Now these two softwares are very much essential tomorrow if you want to do practically. Now that's why I want to know how many people will do tomorrow, because anyway I'll show on my system itself, and parallel you can do it, so that at the end of the session you people need to be known, because the major problem in IoT now I can recommend with Arduino kit and I can show it, but how many people will buy the Arduino kit for this MDB program? Or how many people will buy Raspberry Pi for this MD program? At the end of the day, what the things will happen? Even I can bring a kit and I can show and I can take it, but you people will learn, but you will not practice it, right? So what we are doing is this. Contiki is an embedded operating system, which we are going to write in embedded C or in C language. So whatever you are going to implement it directly later case, what we can do is you can try to, you can take the hardware and you can dump the code and still it can work it out in reality also. So therefore, we'll try to see this instant quantity, and we'll try to simulate it so that it will use both for the research purpose as well as for the testing purpose only. It is also useful for the IoT. These two softwares are very much needed. But before starting of the session itself, I want to know how many people will do it. Madam, please pass the information to me so that I'll go. I want to go slowly or fast. I don't.
Sure, sir.
Before I end this today, I think tomorrow it will take more time. I'll take 10 to 15 minutes tomorrow, because hands-on will take more time than theoretically. So this is an experiment. We'll try to do one or two experiments. As I told you, not to take a screenshot. This is the screenshot which we are going to implement. This is a broader network, sensor network. This is a broader router, and this is external network which we are going to connect. That I'm going to explain in tomorrow session. Okay. So this is an experiment which you're going to do. One or two experiments I'll show in tomorrow session for the IoT. Okay. I think that's it for the day. If you people have any doubts regarding today's session, please let me know, and take the time for installation. And we can, if you have any doubts, you can post in my WhatsApp so that I can respond. Yeah, definitely. You people require PPTs.
All the study material and the recorded videos will be made available at the end of the program.
A few participants are asking for PPT. That's why I asked. Any doubts from the participant side? If people have no doubts, then over to you, madam. I thank each and every participant for bearing me these two sessions, and you have actively participated. Thank you very much.
Thank you, sir, for explaining the protocol architecture of IoT, the basic IoT and connectivity protocols, the challenges in IoT, and how the life can cope up with the era of IoT. Today we had two very interactive and wonderful sessions by Dr. E. Suresh Babu. We will continue with the same speaker tomorrow morning at 10:30 a.m. Thank you very much, sir. I thank all the participants for joining with us. Thank you so much.
Thank you, madam. Thank you, madam. May I leave, madam?
Yes, sir.